Hi all, this is Lakshmi, working as assistant professor in the Department of ECE at SNS. So today I'm here to discuss about the lecture series on embedded systems and IoT. And the unit which I'm going to discuss is about devices and bus standards. The protocol which we are going to discuss here is CAN protocol, that is Controller Area Network Protocol. So this protocol is a multi-master broadcast communication protocol, which allows the multiple devices or nodes to communicate over the shared wire bus. So here, each node can transmit data independently, so making the system highly flexible and fault tolerant. So this is mostly used in vehicle communication purpose and other industrial automation purposes. This kind of protocol is used. So before talking about the protocol in detail, so as we apply design thinking concept, so we have to be clear with the empathy part of this type of protocol. So what the user feels, how the user express their views, all these feedbacks should be collected. So the user might feel they need a reliable communication system for real-time application where the protocol should handle multiple devices efficiently. And also the error detection and the fault tolerance are critical here. And also the wiring. The main concept here is we need minimal wiring and cost-effective solution. So people are more concerned about the data collision and message priority, and also wonders if CAN might meet the high speed and the large data requirements. So design embedded system using CAN controllers and the transceivers, which implements here the message ID prioritization, etc. So the pain points are what are the pain points collected will be like limited bandwidth in the classical CAN protocol and the complexity in understanding the arbitration process and the frame structure. And there is a difficulty in debugging the network issues, and it is not suitable for high data intensive applications. So these are the pain points collected, and the gain here, the user expectations would be like it would be reliable real-time communication, reduced wiring and system cost, etc. So these are all the empathy part of this CAN protocol. So now to understand about the CAN protocol, so let us define the CAN protocol as a multi-master protocol, that is a communication protocol which allows multiple devices to communicate over the shared buses. So here each node will transmit data independently, making the system highly flexible and fault tolerant. This is a message based communication protocol. So which means here there is no specific address. Messages are identified by IDs, and it is highly reliable. Built-in error detection is there in this kind of protocol, and it is mainly for real-time performance, where it works based on priority-based message arbitration, etc. So as discussed, the various features of CAN are it supports multi-master capability, and it is a message-based communication. So where the messages are prioritized based on the ID, that is identifiers, and where the critical data is transmitted first, and then the high reliability, error detection and handling is easy here. Fault confinement, so the nodes which can detect the errors, and flexible data trains. So these are the features of CAN protocol. So the architecture of the CAN protocol consists of the various layers like the physical layer, data link layer, and the typical system would have node. So we call that as the microcontroller, sensors, activators, and the CAN controller, which will handle the protocol logic. We have CAN transceiver, so which interface with the physical bus, and the bus lines where CAN high and CAN low. So we call that as CANH and CANL. So here all the nodes are connected to a common bus. So when a node wants to transmit, it sends a message with an ID. So if multiple nodes transmit simultaneously, in such case arbitration occurs. So the message with lowest ID, that is highest priority, win. So other nodes will stop transmitting and it would retry later. So this ensures collision-free communication. So this is how the CAN protocol works. So the message format for the CAN protocol is sent in form of a frame. So here the main field includes data frame. So we have SOF with start of frame, arbitration field, control field, data field, acknowledgement, CRC, and end of the frame. So on other frame types, like we have the remote error frame and the overload frame. So this is how the message format is structured. And then talking about the error detection and handling in this type. So this is protocol is highly reliable due to the multiple error detection mechanism. So firstly, we can talk about this bit monitoring as each node monitors the bus while transmitting. If it transmits a bit, it detects the different bit on the bus and then it detects a bit error. Okay. And similarly, the stuff error. It uses bit stuffing to ensure there are no more than 5 consecutive bits of same polarity. In CRC, it is a cyclic redundancy check. So this is used to detect the error in the data field. And we have the form error. So that occurs when fixed format in the CAN message does not have the expected format. So if the format is there, any change occurs, this type of error will occur. And then the acknowledgement check. So error occurs while transmitting node. It does not receive any acknowledgement from any other node. So this is how the error is handled in CAN protocol. So the various characteristics, so already we have discussed about this protocol. It is multi-master, low cost, and it is capable of error handling, scalability, etc. So these are all the features of CAN protocol. So application, so the main application of this type of protocol in vehicle communication system, building automation, the automotive system, in aerospace application, and in medical equipment, this kind of protocol is widely used. So today's assessment, which of the following is a key feature of CAN protocol? So it is a multi-master communication protocol. What type of message prioritization is used in CAN? So here it is based on message ID arbitration. Thank you.